Welcome everyone. I want to thank you for joining us today. My name is April and I'm an account manager here at DoubleRadius, where our goal is to help you build better networks. Today, in today's webinar, you're going to learn about delivering powerful next-gen solutions from BEC Technologies. Joining us today from BEC are DeAndre Ladson and Andy Germano. So as the VP of Marketing, DeAndre's role includes developing key technologies, services, and product marketing activities. Andy Germano is the co-founder of BEC and their VP of Business Development. Andy has over 30 years of telecom industry experience with industry leaders including Verizon, Northern Telecom, Qualcomm, Ericsson, and Apple. Before we get started, I want to mention a couple of key things. First, we encourage you to type in your questions into the questions box as you have them. At the end, we'll have a Q&A session and go through them all. Also, after the webinar, a survey will pop up on your screen. It'll take just a minute, and we'd really appreciate your feedback. With that said, let's go ahead and get started. I'll hand it over to DeAndre from BEC Technologies now.
Okay, thank you. Good afternoon, everyone. So for those unfamiliar with BEC Technologies, we're a developer and manufacturer of broadband solutions, supporting advanced services over copper, fiber, and most pertinent to this audience today is wireless technologies such as LTE. We're part of a global group. Our parent company is based in Taipei, Taiwan, but our U.S. headquarters is here in Richardson, Texas, where we have sales, marketing, support, and engineering all here at local central time zone. We're really about simplifying the connectivity and allowing our partners to differentiate themselves, to tap into new markets and opportunities. And that's bolstered by our 46 years in operations and a number of solutions deployed against carrier networks worldwide. So should your opportunities expand beyond North America, global opportunities, we can support those with sales and support in 22 countries and a total number of 220 employees worldwide. Some of the markets we serve, telcos, carriers, service providers and WISP, and others like enterprise, education, and industrial oil and gas markets as well. So what's really next gen about next gen solutions? For most, next gen is just a label applied to a major upgrade of hardware or software product. For BEC, it's really about delivering solutions that address those critical business challenges of today and tomorrow. For the majority of the customers, those challenges are, how do I increase capacity? Enhancing data rates, increasing ARPU, lowering deployment and operating costs. These are some of the challenges we hear on the day-to-day basis from a number of our customers. What are they going to do about new growth opportunities? In the present environment with the pandemic, started a little bit earlier in this year, a lot we're focused on what are we going to do, or how can we address the homework gap, as well. And finally, there's carrier-grade equipment. For a number of years, there's been the notion of throwaway equipment, low-cost solutions, but they don't last, don't allow you to, support SLAs or agreements. So, now the question is, I really need some carrier-grade equipment that's built to last, that supports some of the operations that I need. So those are the challenges for us that a next generation solution should address and account for. Okay. Some of the market trends and drivers for this space, I think a lot of these are pretty common, or guys that you've heard of before. Obviously, the growing connectivity needs. We're pretty much a wireless world at this point. The fixed wireless access has grown. If you look at some numbers from, I think this is from Counterpoint Research, FWA is expected to grow about 60 million to 200 million by 2025. So that's significant in terms of fixed wireless, and a lot of that's going to go from 4G to 5G. 5G is going to be a lot of the driver for that fixed wireless access. Global research in terms of the private LTE market is expected to grow at a 17% CAGR, from 2020 to 2027. And if you look at the number of devices in terms of dollars, that's 1.9 billion in just in 2020 alone. So that's some nice growth rate there. And beyond just, depending on your focus or customer base, there's the increasing growth of IoT M2M. There's sunsetting of some of the 2G, 3G networks out there. The evolving SMB and enterprise space, a lot of access around SD-WAN and leveraging 4G LTE from a connectivity standpoint, and that will only increase with the speeds of 5G NR as well. There's a lot of opportunities in the public safety broadband networks with AT&T kind of building out that, if that's part of your focus in terms of your customer base. And then also, if you look at just LTE in general, from a day one or a primary connectivity standpoint, there's significant growth there. Fiber has always been the be-all for in terms of connectivity, but however, now with some of the advances in LTE in terms of category support, we see a lot of customers going all the way wireless for the primary connectivity, as opposed to waiting, for a fiber circuit that could take 30, 60, 90 days or plus. They're going all LTE, all wireless, because the bandwidth is there and the cost and the expediency of getting started day one is very beneficial to what they need from their business standpoint. So from a wireless standpoint, there's a lot of market and trends and drivers that are going on in the space today. So we have the first poll question here.
So for the first question, we had, in what bands have you already deployed LTE? And 25% said both CBRS and non-CBRS, and 75% said none yet.
Okay, great. We'll continue. So beyond just market drivers, there's also some advancements or key advancements in some of the key technology that has also helped supporting some of that market activity. If you look at what's being driven by 3GPP, the consortium group of companies that kind of drive the cellular standards, such as the advancements from LTE to LTE Advanced Pro, and onwards to 5G NR. It's really about higher throughput, more capacity, increased bandwidth, and there's a little bit of the four items here kind of show some of the key items that drive that. There's a higher modulation, advancement in antennas, carrier aggregation, and then spectrum itself. Access to spectrum has helped drive a lot of this activity as well. And we'll dive a little bit deeper into each one of these. So from a higher order modulation standpoint, it's simply increasing throughput by increasing the number of bits of megahertz in the spectrum. This is an effective way to kind of increase capacity. There's a little bit of trade-off though. The higher the modulation schemes, the less resilient it is to noise and interference. So you can see from a 16 QAM to a 64 QAM, there's kind of a 25% increase in efficiency, onwards to 33% for 64 to 256. Kind of today, in terms of 4G LTE deployment, that's where we are in terms of 256 QAM. Most of the deployments today are across category 12 and higher solutions, and even some of the current 5G NR evaluations and field trials are still 256 QAM modulation. And then onward and upwards toward 5G future, there's the movement toward 1024. But today again, that QAM is sitting right at 256 from that standpoint. Carrier aggregation, is combining multiple carriers, wider channel, more bandwidth. This increases sort of the peak user data rates and overall capacity. It also allows some carriers to exploit, kind of fragmented spectrum allocations as well. So you can see the chart here. It's really talking about 5 CA carrier aggregations, more so from a LTE category 18 standpoint. I think as we move toward 5G, it gets a little bit more complex in the sense of you can potentially aggregate up to 16 component carriers. There's additional bandwidth of maybe 100 megahertz per carrier sub-6. If you're looking at millimeter wave, there's potentially 800 megahertz of bandwidth to aggregate with. And then also you have to factor in some other technologies, LOA, LTU, et cetera, that aggregate a license band with sort of unlicensed 5 gigahertz standpoint as well. So carrier aggregation is another important component of this technology drive to support some of those advances. There's also MIMO antenna technology. I think today the majority of the networks are 4x4. So 4x4 on the base station, that's 4 transmit antennas, and then match that up with the UV standpoint, the user equipment, 4 receive antennas as well, provides better SNR and significant downlink throughput gains when you compare that to 2x2. And this is sort of the path forward for massive MIMO as well. So will significantly increase the data rate and capacity when you're looking at these large antenna arrays of 32 by 32, 64 by 64 and higher. And also they have a higher focus on narrow beams toward the UE as well. So 4x4 there. And finally, there's the diverse spectrum. The CBRS spectrum sharing has really changed the game for this. I think traditionally operators had 2 choices. There was licensed spectrum, exclusive use. It required a license for a particular frequency band or over a geographical area. And then there's kind of unlicensed as well, which 2.4 and 5 gigahertz, and unknown what the kind of the interference, no real protection in that space. But traditionally, those are the 2 spectrums availability for wireless transmission, wireless broadband. And step in CBRS shared spectrum that allows access to this wide 150 megahertz of 3.5 gigahertz spectrum to afford new opportunities and new applications as well. Okay. Second poll question.
All right, so results for this question, first of all, it was in what bands do you plan to deploy or expand deployment of LTE? And 20% said CBRS, 70% said both CBRS and non-CBRS, and then 10% said no plans at this time.
Wow, okay, great. Thanks again for completing the poll. We'll continue. So, I think at this point, everyone pretty much has a good understanding of CBRS. It's a tiered approach to protect several classes of users in the spectrum. The tier 1 incumbents, the Navy, fixed satellite, et cetera, they have full protection from the second tier, which would be PAL, priority access licenses. It's up to 70 megahertz of spectrum in 10 megahertz blocks. And then there's the third tier, GAA, General Authorized Access. They have access, they're allocated 80 megahertz of spectrum. And if there's any unused spectrum from any PAL or incumbents, you could get full access to that 150 megahertz there. You also see our network, BEC sort of network architecture of CBRS, where we have domain proxy functionality that provides an aggregation of a number of CBSDs through our domain proxy, as opposed to having each of those devices connect directly to the SAS. So that could be a significant cost savings from digital certificate support per device. If you're just if you're in a deployment scenario where you need to connect to SAS from a power standpoint, you can leverage our domain proxy to aggregate any number of those devices through. And then also from a SaaS interoperability standpoint, we've completed SaaS interop with Federated, Google, CommScope, and Amdocs. I think possibly Sony and a few others on that list, but in terms of the big four or the most requested, this is where our SaaS interoperability is standing today. I think it's also worth noting that you know, in the recent PAL auction, there's still a little bit more work to go in terms of PAL. I think at this point, we're still waiting on some of the frequency assignments. You know, I guess most bidders are aware of their channel one in that country, but they still don't know the frequency assignment. So that's going to be directed from some of their SaaS partners. And we'll probably have that toward the end of December. And then full PAL support sort of the first of the year, Q1, in terms of you know, the PAL licenses and frequency assignments for all the counties across all the SaaS vendors toward Q1 2021. And then also, it's also worth mentioning, as of 10/17, you know, we have about maybe 80% of those old Part 90 licenses that have expired. You know, they're supposed to convert from Part 90 to Part 96. So that includes, you know, all of those grandfathered protection for some of those WISP. A large majority of those licenses are needed to be transitioned on October 17th. And then the remaining, they probably are, you know, pushed out to end of December, probably top of next year, depending on the extension of their license. But there's has been a lot of activity as of late in the last couple of months with a lot of those Part 90 guys kind of switching over to Part 90 to complete that license upgrade, that, you know, kind of because now they don't have that interference protection because of the grandfathered zone. Okay. So from a CBRS portfolio standpoint, you know, this is a snapshot of the devices here. I won't go through every spec of each solution, but from left to right, you know, the MX100U and 1200 and the 240 series are more kind of targeted toward, you know, private LTE in-building type of deployments. You know, their Category 12 support, you know, with the MX240, there's 4x4 support, you know, number of carrier aggregations, 3CA and a downlink, et cetera. It's noted that the MX1200, the first solution there, also supports license bands. So in your scenario where you may need to also connect to a tier 1 carrier and then have failover to CBRS, or, you know, dual SIM type of connectivity, that solution supports that. There's dual SIM, so it's licensed for license bands and certified for tier 1 carriers, and then it also can support CBRS. The 240 is more of an enterprise gateway if you just kind of need a bridge to bridge Ethernet to CBRS and that type of connectivity. It supports that with 2 gigabit Ethernet ports and you know, 4x4 CBRS connectivity. It also can support industrial applications, IP40 hardened enclosure, and a wide DC voltage range from powering. 6500 series kind of fits in the middle. We've had some deployments where that's been in building or private LTE, and also of late, a lot of interest from schools, school districts, in the sense of private LTE, where they're looking at the 6500 series from an all-in-one router that, you know, can sit into the kid's home, provide extra Ethernet ports for other wired devices. There's Wi-Fi 802.11ac for connection of any wireless devices, and obviously the CBRS connectivity there. So sort of like an all-in-one type of solution that, you know, straddles both more of a private in-building and also fixed wireless as well. We have a lot of carriers or with service providers using that for fixed wireless as well, depending on their deployment. You know, in terms of range, probably out to 1 or 2 miles or so. Beyond that are our outdoor solutions, which are targeted primarily only for fixed wireless. So the 4900R21, that's our outdoor CBRS EUD. EUD meaning in-user device. From an output power standpoint, there's no requirement for this device to connect to SAS. There's no requirement for installation of a CPI, certified professional installer. So in terms of cost of physical deployment of this device, they're much lower because of that, and still provides connectivity at range. Typically, we see this solution used where customers, more non-line of sight deployments, because it has a wider beam path to provide that connectivity into those type of environments. And then moving on further, 6900 R21. This is our high power CPE CBSD category B, full ERP of 38 dBm. The requirement is that it connect to SAS and also be CPI installed. Again, as mentioned earlier, you could run this device through our domain proxy of our management platform. So there's it lowers some of the complexity of installation or control of this device, and also each CPI is required for that. So again, those are some of our CBRS product portfolios there. And I think, from an outdoor standpoint, this kind of goes back to the original comment on one of the challenges when carriers are asking us for carrier grade equipment and no more of the throwaway CPE. So if you look at from our fixed wireless solutions, the outdoors in particular, in terms of the design, these solutions are built for years of dependable operation. Outside of performance, we all know that reliability of solution is just as critical. So there's a rugged enclosure, there's IP68, so protection against that dust and ingress of water. There's corrosion protection with SureTech 650, UV resistant. Most notable is our gore vent protection. So, and those areas where you have wide climate changes and from hot to cold and back, the device does not build any condensation. It allows it to equalize the pressure and provides airflow, so there's no moisture buildup in the solutions, and you won't have to worry about seal failures or component exposures. Once it's out there, it will last. There's also lightning and ESD protection, and all of these devices are wind tunnel tested up to 132 miles per hour. So that's equivalent to tornado speed. So in the sense of having a solution that's going to last and withstand the elements, these devices are kind of purpose built for that operation. And stand behind that. I've talked a lot about 5G in the sense of where some of the technology advances are starting for 4G and kind of migrating over. And I wanted to talk a little bit more about 5G. I mean, there's more than enough details on 5G at this point to be its own separate webinar. But I'll just highlight what I think are some of the key points. I think at this point, everyone's kind of seen, at a high level, what I call the speeds and feeds type of approach. 10x decrease in latency, or 10x increase in throughput, peak data rates of 20 gigabits per second, and maybe a 10x connection density. All of that compared to 4G LTE today. But I think beyond that, if you look at where 5G is kind of envisioned to support a number of services and devices. Again, going back to 3GPP and how they've kind of defined the 3 use cases for 5G. There's EMBB, there's enhanced mobile broadband, there's URLLC, that's a mouthful, ultra reliable low latency communication, and then there's also massive machine type communication, MMTC. Today, some of the early trials and what we're looking at is primarily focused on enhanced mobile broadband. It's higher capacity, faster throughput, and that's been the real driver for fixed wireless access in 5G. Along with the sub-6 and the higher frequency millimeter wave. The URLLC will kind of focus for mission critical communications, lower latency. So think things like robotic surgery, factory automation, autonomous driving, massive kind of IoT, or I guess MMTC will focus on, just massive connectivity of IoT devices, many devices, potentially requiring low bandwidth and also low power. Moving on, if you look at spectrum, 5G natively supports a wide array of spectrum bands and types. There's, low band, mid band, high band, and then again across licensed, shared, and unlicensed spectrum. So there's a lot of opportunity to expand connectivity and leverage all of that spectrum. So if you look at kind of low bands, think of those as more widespread coverage across urban, suburban areas. Mid-band typically offers a good mixture of coverage and then obviously for the high bands and millimeter wave, this is what you need to deliver those ultra high speeds in terms of high speeds connectivity. And then there's also flexible deployment, easier transition. So 5G NR won't require a rip and replacement of your entire network. I think the first wave of 5G networks that we've seen today or started are classified as non-standalone, NSA. Basically, they're leveraging the existing 4G infrastructure, add a 5G radio, 5G NR radio, and leverage your existing 4G core to provide higher speeds and capacity. And then there's SA. If you are probably a new service provider, or you don't have an existing 4G network, you may look at SA and in terms of standalone and deploy a complete end-to-end 5G network there without with SE there's no existing 4G infrastructure to leverage. And I think in summary, you need to look at kind of 5G NR as more of a phased approach. If you look at, again, going back to 3GPP, kind of this consortium that determines the specs and defines the guidelines for 5G, this is kind of spaced out in several of their releases. So today we're on release 15 that focuses a lot on EMBB, that higher throughput, higher capacity. And then there's release 16 was just kind of finalized middle of this year, and we'll start to see that kind of out into play maybe Q1 of 2021, and that focuses on probably URLLC and some others. And then further out is where you kind of get release 17 is more of phase 3, where you can envision all of the benefits of 5G NR as well. So it's really a phased approach. So it'll be over a number of years till we get to the point where we see everything that's envisioned for 5G in terms of the application supports, and then everything in terms of speeds and feeds. And beyond this, again, as I said earlier, this could be multiple webinars on its own. There's other things to consider like dynamic spectrum sharing, mass MIMO of beamforming. Again, that will be very beneficial to those devices. And then there's network slicing as well, where operators can slice portions of their network for specific customer use cases. Okay. And here's our 5G NR portfolio today. The first two solutions, the 8100 and 8230, are sub-6 solutions. These are solutions we have in trials today, and some early adopter customers that are doing some testing of this. So these are sub-6 and also LTE. You can see some of the bands and specifications they're supported. Again, 8100 is more of an indoor device. Just think full residential router, firewall, advanced functionality in terms of VPN capability, dynamic routing, extra gigabit Ethernet ports for other wired devices, Wi-Fi, high power Wi-Fi for other wireless devices in the home as well. And then the 8230 is our outdoor solution, built to withstand the elements and provide, that fixed wireless access or fixed wireless connectivity over, 5G sub-6, and also, in the case of, LTE. So we consider these our dual mode solutions because they allow you to deploy today on your existing 4G LTE infrastructure. And then as you migrate over to 5G, adding a 5G radio, and then slowly building out potentially some areas you may want to go full 5G end-to-end, this device can support what you need today and also tomorrow. So, that dual mode in the sense of LTE and 5G NR sub-6 support. And then for the last two solutions here, is another IDU and ODU. We don't have specific model numbers at this point. These are our middle, these devices will be sub-6 and millimeter wave support. So again, you can see functionality in terms of sub-6 bands are pretty much the same across the product line, but you'll see these solutions in terms of the millimeter wave bands that are support in 257, 258, 260, and 261. Specifically for the ODU, it will be a high power device, so high power millimeter wave support for that. So in summary, I think if you look at the left side sub-6, you think of the ability to further penetrate more solid objects. So think coverage and capacity, and then obviously for the millimeter wave, think the highest possible data rates, and then shorter range for those solutions. Okay. And with everything, we tie all of our solutions back to our cloud management. So think of this as kind of your command center, whether it's one device or thousands. This platform extends the network visibility with complete device management. Excuse me. So in terms of cloud management platform, there's provisioning and control. Functionality that you can do locally to the device can be controlled and done remotely in the cloud. There's data usage analysis, real-time diagnostics. I think where we really excel since we've been primarily focused on carriers is real-time RF measurements. Things like RSSI, SINAR, the ability to chart, the cell ID, the PCI, the ERSN, support PCI lock functionality. Within our cloud, we have a lot of RF information that helps, pretty much show how the device sees the network. So in terms of troubleshooting and understanding that, we have a good handle on that, and we display that information in our cloud. Beyond that, there's proactive alerts and notifications, either by email, text, or SMS. And then there's also an extensible API. If you want to integrate any of this functionality into your own NMS system, your own billing platform, that functionality is available and built to support. And again, for those specific for CBRS applications, the same cloud management platform has integrated domain proxies, so to support the aggregation of multiple CPE CBSDs with any of the SaaS vendors that we fully operate with there. Okay. And beyond the cloud management, I think another important factor is to understand, the installation is extremely important. Any missteps during installation can be significant or have a significant impact in terms of performance and bottom line. If you're looking at multiple truck rolls, you want to do it once and get it right the first time. So SiteSmart Pro was kind of developed for that purpose. It's designed with the input of our carrier customers, some of their field technicians, and also kind of years of experience in this space. And the ultimate goal is to install it right the first time. So this tool ensures proper alignment to the best serving cell site, RF signal tooling, analysis, all of that before you leave the site. Okay. And then finally, I'll sum this up in terms of why BEC. there's longevity in business. We've been around, over 46 years globally, 20 years in North America. We're a developer and a manufacturer. So our solutions, hardware and software, are our designs built in our factories. These aren't contract manufactured by another company, built by us. The only thing that's probably not our key is the cellular radio, which we'll get from Qualcomm or whatever, but the device, the hardware is all ours. Again, if there's any opportunities beyond North America, we can support those globally as well. We have a global presence. There's a lot of differentiated solutions that we have, not really shown in this slide deck today, but there's a number of solutions really based on the applications and use cases that we have beyond just fixed wireless. Technical support and expertise. Our guys not only understand LTE, the technology itself, our devices, but also that knowledge expands to the other components of the LTE network, so the core equipment. And we also have a large ecosystem of partners from a core equipment standpoint that we work and interoperate with on a daily basis to kind of support that support. So that effort, so you just won't have a team that understands one piece of it. We can help troubleshoot and resolve issues all the way from the device, customer prim in, and facilitate that to the back end on the network as well. And then I think I'll close with value performance. It's really about value-driven hardware and delivering, kind of the feature-rich platforms, kind of the lower TCO, total cost of ownership, flexible deployment options, and then multiple devices kind of support, that deployment and use cases of today and some of the future applications. And this is where I'll close. So I guess at this point, we can kind of open up the line for any additional questions and go from there.
Okay, I'll go ahead with the first question. If you have more, you can go ahead and submit them. But our first question is from Samuel. Yes, with CBRS having a CBSDB EIRP limit of 4710 megahertz, does BEC plan to create a high gain CPE device for longer distance communications in rural environments?
Yeah, I think that's always been sort of a roadmap item relative to the business case and cost. I think going up to support the 47, there's some design consideration in terms of the size of the antenna and also some additional costs. But it's sort of at this point waiting to hear the feedback from the core customers in terms of the actual need for that device per se. But yeah, it's something that's been on the roadmap, and I think from a competitive standpoint, there's one or two solutions out there that are now increasing that output power up to that limit, and I think it's something you'll probably end up seeing from us. But at this point, it's something that we can do, and it's been talked about. It's just waiting to get the business case from the customers. Okay.
And our second question is, it just says no band 48 CBRS for 5G and R.
Yeah, there's 48 for CBRS. I guess if I go back to this slide, maybe that it should be listed there. And I think if you look at some
here, so yeah, so it's listed there under the supported bands, but just under the LTE. So the LTE is a category 20 support, and then there's a subset of bands that actually have the 5G NR coding scheme, whereas the other bands are just LTE in a category 20. So you might see a slight difference in performance under the 5G NR in a like-for-like frequency. It's about less than 20% potential improvement.
Oh, yeah, you're correct. It is missing from the slide.
That's in the current chipset support version. So in a future edition, could have the band 48 moving over to 5G NR support. but in this current version, it's just under LTE, category 20 LTE, which should be able to do up to 3 gigabits.
Our next question was for the 5G and RIDU and ODU, do we expect any improvements in spectral efficiency in sub 6 gigahertz bands?
Yeah, this is Andy again. So basically, I think the question is around will you get better spectral efficiency from 5G in sub 6 versus 5G in millimeter wave? And there'll be some benefits in sub 6 in terms of longer propagation. There'll be less bandwidth available, like as DeAndre mentioned. With 5G, you'll be able to aggregate 4 100 megahertz carriers to get 400 megahertz of spectrum allocated to get to that 3 gigabit capability. Whereas in the low band, you're lucky if you get 20 or more. But there are a lot of different band combinations where you can actually aggregate bands between, say, band 66, band 2, band 12. So there's a lot of bands where you can pull that carrier aggregation. But I don't think you'll necessarily see better spectral efficiency from the same coding type versus the same coding type, even though it's a different frequency, if that makes sense. DeAndre, do you want to add to that?
No, I think you're spot on. I think you clarified the question. So I think we're good there. Next question.
Yes, next question is, what are the respective ranges of your outdoor products? And as antenna height, no doubt, is a major criteria.
Yeah, I think range is relative to the environment, and but if you're looking at CRS in general, we have some customers with our 6900 well out at 18 miles or so. I think typical deployments are well within 9 or 8 to 10 mile range or so, but we've got some deployments that are really far out. And then if you're looking at from an IDU standpoint, the typical deployment for those solutions are well within 2 mile range or so. But if you're looking at the furthest solution in terms of distance, it would be obviously the high power 6900 R21. But the distance is kind of relative to the environment, your deployment type, antenna height. There's a lot of factors in there, but
so that's a good question. Yeah, it's almost impossible to answer because, like I said, it depends on if you're in a flat area versus a lot of trees versus mountains and canyons. But we've got a site up in Montana that's 27 miles from the nearest tower, and they get 11 megabits out to that mining site. So certainly the 6900 with its narrow beam width directional antenna is designed for rural applications, long range. That 27 miles from the tower is likely in a 700 megahertz type of a frequency. So you're not going to get that in the millimeter wave. Obviously, we've got some customers that are currently testing now our 365, so band 48 CBRS in 9 miles, 15 miles. We've got a lot of test results that are published. We'd be glad to share some of those just to show different range rates for different environments. But in general, we have a rural, suburban, urban philosophy just without any other information. And so, yeah, the 6900 with its narrower beam width, higher power is well designed for rural applications. As much line of sight as possible with the narrower beam width antenna. Whereas the 4900 is designed more for suburban, where you're going to get some multipath, some bouncing of the signal off suburban buildings and structures. It's a much wider beam width compared to the 6900. And then the millimeter wave we see is more of an urban environment technology. It's not going to have as long range. And same thing with the gigabit, like DeAndre mentioned, the new gigabit router that's designed the higher modulation. That's generally not going to go as far from the tower as say a lower data rate solution. That being said, we're starting to see some reports coming in with our testing of some pretty good distances from the tower, with even in the millimeter wave and the gigabit getting out 5 miles out, and so that's really nice. And as DeAndre mentioned, the questions about outdoor but also the indoor, especially in the higher frequency, we don't see as much range on the indoor units as you'll get from the outdoor. But in the lower band, lower frequency, like 600, 700, indoor solutions work really great. Longer range.
Yeah, if you look at from an indoor solution standpoint, the majority of the time, the placement of the device is placed for best Wi-Fi, not best cellular signal. So if you can adjust that placement near a window or et cetera, you could get, better performance. But typically, from an IDU standpoint, it's placed where they can get the best Wi-Fi coverage, which, affects, cellular performance and, et cetera with that. Okay, next question.
When are the 5G NR solutions expected?
Well, currently we're looking at probably end of Q1 2021. These devices are sampling now for some of our early customers. So end of Q1 is when we look at. We'll be ready primarily from 8110, the IDU solution, and then shortly after that, the 8230, the ODU will follow.
5G NR incorporates integrated backhaul, correct? So your products would do that too?
No, we're just a CPE vendor these are just connection to the tower from the customer prim. There's no backhaul component of the CPE device.
That being said, people do use our solution as a way to power, say, a small cell, or we do have a couple products in the portfolio that you can use as a point-to-point. But in general, as DeAndre mentioned, it's really customer premise equipment. So people would use the LTE or the 5G as the backhaul to feed into their as a gateway device, a router device, or an integrated Wi-Fi type device. But certainly there are applications where you could use the BEC equipment to feed into a small cell or something like that for local coverage.
Okay, and that answered the last question that we had as well. So it looks like we have a wrap there. I'd like to thank BEC for explaining today how we can use their technology to deliver next-gen solutions. As we close out, please remember to complete our quick survey that will pop up on your screen, as we'd really like your feedback. Also, if you have any other questions you weren't able to ask, you'll be able to ask them in the survey, and we'll be sure to get you the answer. Also, if you can reach out directly to your DoubleRadius account manager for additional questions or information, that's a great way to get in touch. Thanks again for joining us, everyone. Stay safe, and we'll see you next time.
Thank you.